When you work with Solidworks, you'll generally be working with three file types: parts, assemblies, and drawings. I'll be covering each of these in this course, beginning with a focus on creating parts. Parts will be at the center of your designs in Solidworks. As you will see later in the course, parts are the basis for creating assemblies and drawings. As you proceed throughout the course, you'll see that parts themselves are made up of building blocks called features. There are two types of features: applied features and sketched features. Applied features are directly applied to parts, like rounding off an edge, while sketched features must begin with two-dimensional profiles called sketches. A sketch is where you create the 2D geometry that will serve as the foundation of three-dimensional features. Sketches are created using simple tools, such as lines, rectangles, and circles. These shapes can be defined very precisely using dimensions and something called geometric relations that we'll look at a bit later. First, we'll look at a concept that creates confusion very often for new users: the concept of edit sketch mode. By default, when you begin a new part file, you'll be in a mode called editing part mode. If you look down here in the corner, you'll see that Solidworks tells me I'm in editing part mode. If you don't see this message bar, called the status bar, go to the View drop-down menu, and under User Interface, select Status Bar. In Solidworks, when you're creating parts, you can be in one of two modes: editing part or editing sketch. If you keep an eye on the status bar, you'll always know what mode you're currently working in. So why are there two modes? Well, every feature you create as you build a 3D model falls into one of two categories: either a sketched feature or an applied feature. If you want to create a sketched feature, you have to start by using editing sketch mode. If you want to create an applied feature, you do it in editing part mode. Now that you know there are two modes for creating these different types of features, the question is, how do you switch between the two modes? There are actually several ways to do this. One is to simply begin creating a sketch-based feature. If you take a look at the command manager, there are very few icons that are not grayed out. The first group of features are sketch-based features. Notice there are only two features available: the extruded boss feature and revolved boss feature. If I hover my cursor over each icon, you can see a tooltip appears with the name of the feature and a description of what it does. I'll click the extruded boss icon, and a few things happen. First, you can see planes appeared in the graphics area. And if I hover the cursor over them, you can see they highlight in a different color. Over on the left, you can see that a message appears, prompting me to select one of the planes which have appeared in the graphics area. You can also see that a plane icon and a face icon appear next to my cursor, letting me know that I need to select a plane or face. You have the option of selecting the front, top, or right plane. I'll click on the front plane, and the view rotates so that I'm looking directly at the front plane because the front plane is now the sketch plane. The status bar at the bottom of the screen changes to indicate that I'm now editing a sketch. There are other indicators that let you know you are in editing sketch mode. First of all, Solidworks adds a sketch to the feature manager tree. You can also see these transparent images show up on the top right corner. These are buttons that we'll take a look at a bit later, but also indicate that you're in edit sketch mode. Finally, and most importantly, the command manager automatically changes to display the sketch toolbar. Once you're in edit sketch mode, to get out, you can do one of the following things. You can click the exit sketch button on the sketch toolbar, or you can click the exit sketch icon in the confirmation corner. This icon is the same as the exit sketch button. It simply closes the sketch you're working on and saves all changes. If you click the red X icon, you have the option of discarding any changes you may have made. Finally, you can also hit the D key, and a dialog box appears with the same icons found in the confirmation corner. Earlier, I got into edit sketch mode by clicking on the extruded boss feature and choosing a sketch plane to begin a sketch for that feature. That is one way of starting a sketch. You can also get into edit sketch mode by switching to the sketch tab of the command manager and clicking sketch. I'll click the sketch button, and you can see that I'm prompted to select a plane or face to sketch on, just like before. The first sketch tool we'll take a look at is the line. First, notice that the line tool has a drop-down menu containing the line tool, the center line tool, and the midpoint line tool. I'll discuss the center line and midpoint tools in a later lesson. You can also locate the line tool from Tools, Sketch Entities, or by right-clicking in the graphics area under Sketch Entities, or by hitting the S key, or by using mouse gestures by holding down the right mouse button and dragging to the left. For now, I'll activate the line tool by clicking the main line icon. As I move the cursor into the graphics area, you see that it has changed to a pencil with the line command icon next to it. This feature is to let me know which tool is active. If I click on other sketch tools icons, you can see the cursor feedback will change. Let me get back to the line tool. To create a line, I'll click anywhere to begin, move my cursor, and click again. After clicking the second time, you can see a point was added and another line segment has started. This is a convenient way to create a chain of lines. I'll simply click to continue, and more line segments are added. To end the chain of lines, you can right-click and select End Chain from the pop-up menu. Another way is to double-click. When you double-click, the last point you added becomes the end of the chain. There is a slight variation to this method of creating geometry that many users prefer. Instead of clicking to begin a line segment, then moving the cursor and clicking again to add a point, you have the option of click dragging. I'll click and keep the mouse button pressed. Then I'll drag to the location where I want the line segment to end and release the button. The difference, as you can see, is that no chain of lines is created, just one segment. For those that don't want to worry about ending chains, either by right-clicking or double-clicking, this might be a better method. Other sketch tools work very much like the line tool. Let me clear this sketch by deleting these lines. To delete sketch items, all you have to do is select them and press delete on your keyboard. This can be an annoying stumbling block that trips up many new users. To select something in Solidworks, you click on it. However, because I still have the line tool activated, when I click on these lines, I end up beginning a new line. Typically, a new user will notice this, and to try to avoid this new line, they will bring their cursor back to the beginning very carefully, hoping that Solidworks will forget all about the new line. The problem with this is that you end up with these little tiny specks of lines that can cause nightmares down the road. To avoid all of this trouble, just remember to turn off whatever sketch tool you might have on before you try to select things. Turning a sketch tool off is easy. Either click again on the active tool, or click on the select icon, the icon with the picture of a cursor. For those of you that like to use right-click shortcuts, you can also right-click and choose Select from the pop-up menu. Another very popular method to exit from an active tool in Solidworks and return to the Select tool is to hit the Escape key on your keyboard. Now, with the Select tool active, I can now click on these lines to select them, and press Delete on the keyboard to delete them. If you want to select more than one line, just hold down the Control key as you click on lines. You can see several lines are highlighted, meaning that they are selected. One last trick to selecting items in a sketch. If you have a group of items to select, you can click and drag a box around them to select them all at once. Dragging a box from the left to right will select any elements that are completely inside of the box. Notice the box selection appears in a solid line. Dragging from the right to left will select any elements inside of the box or crossing the box boundaries. This time, notice the box selection appears with a dashed line. When I press delete, they all go away. The other two sketch tools under the Line tool dropdown are the Center Line and Midpoint Line tools. They work a lot like the Line tool, with just a few differences. These tools are also found in the Tools dropdown menu under Sketch Entities. The right-click menu, or from the Line dropdown on the S shortcut menu. I'll open the Center Line tool by expanding the Line tool dropdown and clicking the Center Line icon. You can sketch a center line using any of the methods used to sketch a line. In this case, I'll click to place the first endpoint, click again for the second, and double-click to end the line. Notice that this creates a dashed line, which indicates that the center line is construction geometry. Sketch entities that are construction geometry are ignored when the sketch is used in a feature, making construction geometry like center lines useful for centering sketches, mirroring sketch entities, as well as many more applications that you'll encounter as you go through this course. The last tool on the Line dropdown is the Midpoint Line. This tool was added in SolidWorks 2015 and is another useful method of sketching a line. I'll click to start the line, and as I move the cursor away, notice that the line is being sketched in two directions, expanding out from the center point. I'll click to end the line, double-click to end the chain, and press the Escape key to exit the Midpoint Line command. You can see that a sketch point was automatically created at the center of the line. And if I drag either of the endpoints of the line, the sketch point always stays centered. There are many cases in which this tool could save time. If you want to center a sketch line on the origin, for example, you would simply click to place the midpoint of the line on the origin. Click again to end the line, and the line is perfectly centered, no matter the size of the line. One last thing before I move on. If you have the regular line tool active, but you want to sketch either a center line or a midpoint line, you can go to the Insert Line Property Manager, and under Options, enable For Construction or a Midpoint Line to sketch either a center line or a midpoint line. If you want, you could even select both options to create a midpoint line as construction geometry. Let's look at another common sketch tool. You saw how easy the Line tool was to use. The Rectangle tool is similar. It too has a drop-down menu and contains a number of methods of creating a rectangle. I'll select the basic corner rectangle. Once activated, all you do is click somewhere to begin the rectangle and click again to end it. If you prefer the click-drag method that we saw earlier, you can use it to create rectangles as well. You might have noticed that the area within the rectangle is shaded. This is the result of the Shaded Sketch Contours setting. Closed sketch contours and subcontours are now viewed as shaded entities. You can activate this setting under Tools and Sketch Settings. You are able to move the shaded area by simply clicking in the shaded area and dragging the geometry. Apply relations to entities. Check whether or not a shape is fully closed, and much more. If you want this option available to you on the Command Manager, simply search for it here and drag it onto it. You can now quickly enable or disable it. I'll discuss this setting in more depth in a later lesson. You will notice in the Property Manager that you can choose to switch to one of the other rectangle tools without having to exit the tool altogether. If you look closely at the icons, you will see points and a number associated to each point. Each point is a mouse click in the graphics area, and the number is what order the click is in. I'll switch to the Center Rectangle tool, and you will notice I need the first click to be the middle of the rectangle, and the second click is a corner. I'll move to the graphics area, click once for the middle, and once for a corner. You can also click and drag this tool as well if you prefer. The next rectangle tool is the 3-point corner rectangle. This tool requires 3 clicks, and each click will be a corner of the rectangle. You can also click and drag this tool. I'll click and drag from the first point to the second point. Release the mouse button, and click and drag from the second point to the third point. Next is the 3-point center rectangle. I'll click once for the center, once for the middle of a side, and once more for a corner. Finally, I have the parallelogram tool, which needs 3 clicks for each of its corners. When I sketched the center point and 3-point center rectangles, you may have noticed that construction lines were automatically added along the diagonals. These lines can be useful when centering the rectangles or using symmetry in sketches. In SolidWorks 2015 or later, there are a few additional options that can be set for these center lines in the Rectangle Property Manager. In addition to the center point and 3-point center type rectangle, where center lines are always present, you also have the option to toggle center lines on in all of the other types of rectangles as well. If I choose the corner rectangle, for example, and check the Add Construction Lines box, the corner rectangle will now be created with center lines. In addition, for all types where construction lines are enabled, you can choose between positioning the center lines from each corner along the diagonals or from the midpoint of each side. Just make sure you set the options before you sketch the rectangle, as these options only have an effect on rectangles sketched after the options are set. Before I wrap up, I'd like to mention one more thing about the drop-down menus. If I select the parallelogram from the rectangle drop-down menu, you can see that the parallelogram icon replaces the original corner rectangle in the toolbar. If I want to use the corner rectangle tool that opened when I first selected this icon, I have to open the drop-down menu and select it. Otherwise, the parallelogram icon is now the default tool. This consolidated property manager is also used in the circle and arc tools, which we will discuss in the next lesson. Circles and arcs are defined a bit differently than lines and rectangles. Let's start with the circle. If I open the drop-down menu for the circle tool, you can see that I have the option to create a regular circle or a perimeter circle. You can also access the circle tools from the S key shortcut menu by right-clicking in the graphics area under Sketch Entities, or with mouse gestures. I'll activate the regular circle tool and click to locate the center, move the cursor, and then click again to define the radius of the circle. The click-drag method works as well. I'll click to define the center, hold down the mouse button, and release it to define the radius. Next, I will switch to the perimeter circle. As you can see from the icon, I need 3 clicks, each representing a placement of the outside of the circle. Notice that the circles I've drawn are shaded like the rectangles in the previous lesson, meaning they are also a closed sketch contour. Creating arcs is slightly different. If you notice in the Arc Tool drop-down menu, there are 3 ways to define an arc in SolidWorks: a center point arc, tangent arc or a 3-point arc. If I right-click in the graphics area, you can see that I can also access art tools from the menu. I can also press S on my keyboard to bring up my shortcut bar. Let's start with the center point arc. I'll activate it by selecting it from the right-click menu. I'll click to define the center, and then move the cursor to see a preview of the arc. Notice there is a line from the center to the cursor. This line is the radius of the arc, but it will also be the beginning of the arc. If I click here, the arc will begin here. As I move the cursor, notice the arc is being drawn from the point where I clicked. Once the arc appears the way I want, I click once more to finish it. The next type of arc we'll go over is the tangent arc. As the name implies, this arc has to be tangent to something. If I activate it and click in open space, Solidworks will let me know that I need to select an endpoint of a sketch segment. To continue with this example, let me first sketch a line. Now, I can use the line as the starting point of the tangent arc. I'll click on the endpoint of the line and drag the cursor away. You immediately see a preview of the tangent arc. To finish the arc, I'll just click once again. There are some options available as you sketch a tangent arc. Let's sketch another one on the other end of the line. After clicking the end of the line, if I move the cursor away from the line, I'll get a tangent arc just like the first time. However, if I return the cursor back to the starting point and move it toward the line, notice I get a tangent arc in the opposite direction. If I return the cursor once more and move my cursor away from the line in a perpendicular direction, I'll get a perpendicular arc. So even though the arc is called a tangent arc, there are various results you can get when using this tool. The last type of arc is the 3-point arc. I'll activate the 3-point arc by using the S key shortcut bar. I'll click to begin the arc, and click again to end the arc. So far, the beginning and end of the arc are established, but the arc itself is not defined. By simply moving the cursor from one side to the other, I can define the position and size of the arc. When the preview looks okay, I'll click once more to finish. To recap, the 3-point arc is defined by clicking 3 times, once to start the arc, once to end it, and a third time to define its size. There is one additional and very useful method to create an arc that does not appear on the sketch toolbar. It's called auto-transitioning and is accessed from the line tool. Begin a sketch line, and to switch to an arc, simply move your cursor back to the beginning of the line segment and move your cursor off in the direction you would like the arc to continue. Notice the line tool has switched to an arc. You can control the direction of the arc by moving your mouse in a different direction from the starting point. After completing the arc, the sketch line tool is reactivated. Solidworks allows you to create a variety of slots using the slot sketch tool in one easy step. You can find the slot tool on the sketch toolbar by expanding the slot icon. Here, you can see all the different types of slots you can create: straight slot, center point straight slot, 3-point arc slot, and center point arc slot. You can also find these sketch tools by going to the Tools drop-down menu under Sketch Entities. I'll select the straight slot. Just like with the other sketch tools, in the Property Manager, you can toggle through the different types of slots, and you can see the numbered mouse clicks used to create each slot. I'll begin with the straight slot. The first 2 clicks define the length, and the third click defines the thickness of the slot. So I'll click once to define the first point, once again to define the length, and a last time to define the slot thickness. Notice the Property Manager remains active in case I want to continue adding dimensions. Before I show you the other slot types, you can see that there's a checkbox that says Add Dimensions. I'll check it so that Solidworks automatically adds dimensions to the slot after I sketch it. You can choose to add the dimensions from the center of each semicircle, or the overall length of the slot. I'll select Center to Center, and create a slot. After I place the third point, you can see the dimensions were automatically added. The next type of slot is the center point straight slot. The first click on the screen defines the center of the slot. The second click defines the distance from the center to the arc, and the third click defines the thickness of the slot. The next 2 slot types work just like the arc tools, but with an extra step to define the width of the slot. I'll start with the 3-point arc slot. I'll click once for one endpoint of the arc, click again for the other side. A third click will give the arc its radius, and finally, a fourth click will give the slot its thickness. You can see the dimensions that are added are angle of the arc, distance from the center, and the thickness of the slot. Let me clear the Add Dimensions checkbox. The last slot type is the center point arc slot. I'll click once for the center of the arc, click again for the start of the arc, click a third time to define the length of the arc, and finally click a fourth time to define the thickness of the slot. In the previous exercises, you may have noticed some feedback on the screen as I sketched lines and arcs. For example, I'll start a line on the origin. I'll click the S key to bring up the shortcut menu, and click on the line icon. Next, I'll click on the origin to place the first endpoint. If I move the cursor close to the horizontal, a yellow flag with a horizontal line appears next to my cursor. If I instead move the cursor close to the vertical, the feedback updates. And now a yellow flag with a vertical line appears. This symbol represents an automatic sketch relation. This means that if I click to finish the line while the flag is still showing, then the sketch relation is automatically added to the line. In this case, a vertical sketch relation was added. Sketch relations are a way for you to control the geometry you sketch. They control the way lines and other sketch entities behave. For instance, if I try to move the vertical line I just sketched, I can make the line longer or shorter. However, no matter where I drag the cursor, the line remains vertical. Let me sketch another line. Starting at the upper endpoint, if I move the cursor away from the endpoint, you can see a different type of feedback. Yellow dotted lines that extend across the graphics area. These are inference lines. They let you utilize existing geometry to create new sketch relations. For example, if I sketch a vertical line while the inference lines are displayed, notice a coincident and vertical will be added. I'll click to place the line, and you can see the two sketch relations added. Let me quickly sketch a diagonal line. Now, if I move the cursor towards the inference line, you can see a perpendicular, or collinear sketch relation appear. Here again, if I were to complete the line while these symbols are showing, the sketch relation would be added automatically. I'll click to add a perpendicular relation. Now I'll click and drag the diagonal I sketched before. And you can see that no matter where I move it, the perpendicular relation is maintained. This method of adding sketch relations on the fly is called creating automatic geometric relations. Let's take a look at a few other automatic relations. If you have an existing line, and you want to create another line parallel or perpendicular to it, you first have to click the existing line so that Solidworks knows you want to create a relation with it. To create a parallel line to this existing line, I'll first select it, and from the shortcut menu, I'll click Line. I'll click to place the first endpoint, and notice that the inference lines appear. Also, the original line is highlighted to indicate that it will create a relation between the two lines. I'll click to create a parallel line, and notice that a parallel sketch relation flag with a number appears next to both lines. When I click and drag the endpoint of one of the lines, notice they remain parallel. Another commonly used automatic relation is creating a line tangent to a circle. I'll begin by creating a circle. Notice that the sketch circle I just created is still highlighted in orange. This is a convenient function in Solidworks because I now have the ability to create an automatic relation to the previous sketch geometry with whichever element I sketch next. This is actually due to a function called a sketch snap that we will get into later on. With the circle still active, I'll switch to the line command from the command manager. To create the tangent relation, I'll simply begin the line on the perimeter of the circle and drag off at an angle. And you can see that the line I'm sketching is forced to be tangent to the circle. Notice that wherever I drag my cursor, the line remains tangent to the circle. If I were to click again to end the line, I'll have a line with a tangent geometric relation with the circle. If I don't want to have a tangent line, all I have to do is move the cursor back to the beginning of the line. When I do this, notice that two inference lines appear. One is for tangent in both directions. The other is to create a line coincident to the circle's center, or in other words, a perpendicular line at that point on the circle. You can follow either of these inferences to create an automatic sketch relation, or not follow either and simply create a line that is coincident to the circle. The feedback you see as you sketch allows you to capture geometric relations automatically. However, you can also add relations manually. For example, if I want to make this angled line horizontal, all I need to do is select it. When I do so, you see the Feature Manager tree changes to show me the properties of the line. This panel is called the Property Manager. The options I want to focus on are under Add Relations. These are geometric relations that can be added to the line. I'll select the horizontal relation, and you can see the line will change to be horizontal. This can also be done through the Context toolbar. When I select a sketch segment, available geometric relations are visible in the top row of the Context toolbar. You will also notice that one of the relations in the toolbar has a dashed box around it, showing which one of the options the sketch segment is already closest to. In this case, the sketch line is closer to being horizontal than vertical, so the horizontal relation has the dashed box around it. If you are new to SolidWorks and geometric relations, I would suggest using the Property Manager. This way, you can see the name of the relation next to each icon. Once you get more familiar with geometric relations, you might find it faster to use the Context toolbar instead. The options you see in both the Property Manager and the Context toolbar depend on the geometry you select. For instance, at the end of this line, I'll attach a 3-point arc. To make the arc tangent to the line, I'll select both items by holding down my Control key and selecting both. And now you see the geometric relations that are possible between the line and the arc. One of the options is tangent. Notice the horizontal option is no longer on the list because it doesn't make sense with the line and arc selected. In addition to control selecting two entities to add relations from the Context toolbar, you can also simply click on the shared endpoint of two entities, and the toolbar will appear displaying the relations that can be added between them. Another method of adding geometric relations is by clicking on this icon here. It's called Add Relation. The Add Relations dialog appears in the Property Manager. I can add geometric relations between different sketch elements by selecting them in the graphics area, and Solidworks tells me what relations are possible between the selected segments. Between this line and circle, I will create a tangent relation by selecting both of them and simply clicking the Tangent button. Now, the newly added relation appears in the existing relations window here. Notice the Property Manager for Add Relation is pinned by default. This allows you to create multiple geometric relations without having to relaunch the command. Geometric relations can also be removed by clicking on the flag representing the relation. The two sketch entities that are related will highlight. In the case of this line, which is coincident with the circle, the endpoint of the line and the circle highlight. In the case of the tangent relation, the circle and the line highlight. To delete a relation, simply click on it and hit the delete key on your keyboard, and the relation is removed. Another method of deleting relations is to select the sketch element that has the relation. By doing this, any geometric relations associated with that piece of geometry will appear in the Property Manager in the existing relations window. You can then select the relation in the existing relations window. The elements that are related and the associated relation flag will highlight. Then, simply hit the delete key on your keyboard, or select delete from the right-click menu. You can also view a listing of all geometric relations using the Display/Delete Relations icon located here. Not only can you view all of the relations in the current sketch, you can also delete them if you need to. One more useful option here is this drop-down list. We'll learn later that geometric relations fall into several categories. This list allows you to filter out only certain types. It's very useful when working with sketches to be able to see the relations between sketch elements. So the geometric relation flags are very helpful. If you don't like working with them, or perhaps have a sketch that has so many geometric relations it becomes cumbersome to view the screen, you can turn off the display of the flags by going to View, Hide/Show, Sketch Relations. The use of geometric relations is one way to control sketch geometry. The other method is by using dimensions to define the size of geometry. Let's take a look at how to use dimensions next. As you create sketch geometry, you can see a number next to your cursor. I'll start the line command, and you can see the number as I sketch the line. This number represents the length of the line. If I sketch a circle, this number represents the radius of the circle. However, this number does not control the geometry. What I mean is, if I click and drag the line or the circle, you can see they are still free to change size. In fact, the only purpose of the number is to give you a rough idea of the size you are working with. If you know you need a line that is 1 inch long, this number is a good guide so you don't sketch a line that is 10 inches long. A good rule of thumb when sketching is to try and keep your geometry close to the size it will end up. You don't have to be precise, just try to be in the right ballpark. The way to precisely control the size of geometry is to use dimensions. To do so, you want to use the Smart Dimension tool. You can access it here. Or you can press the S key and select Smart Dimension from the shortcut toolbar. Or you can use a mouse gesture and gesture straight up to launch the Smart Dimension tool. The reason this is called the Smart Dimension tool is because there are multiple dimension tools in SolidWorks, including lengths, angles, diameters, and so on. And the Smart Dimension tool allows you to add all of these different dimensions with a single tool. This functionality is available with the Smart Dimension tool because SolidWorks knows the type of dimension needed based on the geometry you select. For instance, to dimension this circle, I'll click on it once, I'll move the cursor, and click again to position the dimension, and you can see a spin box pop up. To change the size of the circle, you can type in a value using your keyboard, or you can press the up and down arrows, as well as dragging the thumb wheel here to increase or decrease the diameter of the circle. You can also type in a name in the box above for the dimension if you want. I'll show you where these dimension names come into play later in the course. I'll type in a name and value. And to accept, simply click the green check, or press Enter on your keyboard. If you change your mind, there are a few ways that you can edit the dimension. You can double-click the dimension to bring up the spin box again, or you can click once on the leader to bring up the Dimension Property Manager, where you can adjust the value and name here. Or if you have Instant 2D turned on, you can click once on the number to change the value. If you don't have Instant 2D shown in the Sketch Command Manager, it can be added from the Customize menu under Options. Let's see what happens when you use the Smart Dimension tool on different types of geometry. If I click a line, like the side of this rectangle, you can see Solidworks recognize that I need a length. I'll click once more to position the dimension. Type in a value, and press Enter. You do have options on what to select. For a line, I can also click the endpoints of the line and establish its length that way. If you haven't added the dimension, and you make any incorrect selections, you can press the Escape key to undo the last selection, and select another entity instead. You can also dimension sketch entities right from the Context toolbar. To dimension the length of this line, I'll make sure Smart Dimension is not active. Select the line, and from the Context toolbar, I'll click the Auto Insert Dimension icon. When I do, the Modify Dimension dialog pops up. I'll add the dimensions, click the green check, and you can see the dimension is automatically added. When you select an angled line, you can establish either the true length of the line or the vertical or horizontal length. I'll select one of the angled lines and move the cursor. You can see I can either add the true length of the line, the vertical length, or the horizontal length. I'm not clicking anything as I do this. I'm simply moving the cursor. When you're happy with the alignment, simply click to type in a value. Suppose you want the true length of this line, but you want to position the dimension here. As you can see, the alignment of the dimension changes, and you no longer have the true length. To lock the dimension into a specific alignment, just right-click when you have the alignment you want. Once you right-click, notice that no matter where I move the cursor, the alignment remains the same. To unlock the alignment, right-click once more. After putting in a dimension, you can drag the attachment points to change where the dimension is attached. This is especially helpful when dimensioning to circles and arcs. When I put in a dimension from this line to this circle, you can see that SolidWorks automatically attached the dimension to the center point of the circle. If you intended to measure to the circle itself, simply click and drag this attachment point to the inside or outside to change it. After you have dimensions in place, you can easily modify them or delete them. Deleting them is easy. Just like any other sketch entity, you click to select a dimension and press Delete on your keyboard. Be careful not to click on the value, or you might accidentally bring up the dialog box. You can select several dimensions using Control Selection and delete them at the same time. Numeric Sketch Input is a dimensioning feature that allows you to specify dimensions while you're creating sketch entities. In order to use Numeric Sketch Input, you must first turn it on. One way to do this is by going to Options, System Options, Sketch, and checking Enable On-Screen Numeric Input on Entity Creation. I'll leave this option and the one under it unchecked for now. I'll click Cancel to exit the Options window. A quicker way to turn on Numeric Sketch Input is by right-clicking while in a sketch and clicking on the Sketch Numeric Input button. I like this method because it allows you to quickly turn it on and off from the pop-up menu. I'll turn it on, and you can see that as I sketch a line, the dimension appears next to it. I can enter a length on my keyboard and press Enter to quickly dimension it. However, you might have noticed that although the line is the length that I entered, no dimension was added to the line. Let's see why. I'll switch to the Rectangle tool. Notice in the Property Manager, there is an option to add dimensions. I can also right-click it to find the same Add Dimension button in the right-click menu. I'll hit Escape to exit the right-click menu and continue to sketch a rectangle. Before I release the mouse button, notice that I can press Tab, and the Numeric Sketch Input will toggle between the width and length dimensions. I'll type in the value for one of them, press Tab, and type in the dimension for the other. When I'm finished, I'll press Enter, and the dimensions are added. Or if you just want to have dimensions created but don't want to define them, you can simply click and drag to create the rectangle as you normally would. And when you click again, dimensions are added to the sketch. Let me delete these sketch entities. Now let me quickly go back to the options. And from the Sketch menu, I'll enable Create Dimension only when value is entered. Earlier, without the option enabled, dimensions were automatically created with any sketch, even if I didn't define the dimensions. But what if you only want to add dimensions to certain sketch entities? One way would be to simply enable numeric sketch input when you want to use it, and disable it when you don't. But this can take a lot of time. Instead, with the setting turned on, notice that if I sketch a rectangle, the dimensions still appear. But if I click to finish, no dimensions are created. I'll sketch another rectangle. And if I instead type in values from my keyboard and press the Enter key on the keyboard, the dimensions are added to the sketch. Numeric sketch input can often save you time in defining and dimensioning your sketches, so it's a good idea to take advantage of all the different settings and options available. But if you don't want to add dimensions, just click to sketch as normal. You may have noticed during previous examples that sketch geometry can appear in different colors. When I first create geometry, it appears light blue. This light blue color simply indicates that something is selected. You can see as I go on to the next piece of geometry that the color changes to dark blue. The color of newly created geometry is dark blue, which indicates that the geometry is underdefined. This type of geometry can be easily changed by clicking and dragging it. As you begin to add definition to geometry, for instance, if I take this point and drag it to the origin, this creates a coincident geometric relation. And this point and both lines become black. Black geometry indicates that sketch segments are fully defined. As you can see, both the horizontal and vertical lines are fully defined because they're pinned to the origin and have either a horizontal or vertical geometric relation applied to them. The only thing about them that remains dark blue, or underdefined, are the endpoints, since they can still be moved. If I use a dimension, the point also becomes black, and it can no longer be moved. If I place one more dimension, the entire rectangle becomes black, or fully defined. When an entire sketch is fully defined, you will see this reported here in the status bar. When creating sketches in Solidworks, you don't have to fully define sketches. This is a nice feature because oftentimes, especially in the early stages of design, you may not know what dimensions you will be using, but you have a general idea as to the shape. Having said that, it's generally considered good practice to fully define sketches once you finalize a design, so that when you go to manufacturing, you know that there are no arbitrary values defining your part. The sketch color coding is a very easy way to identify sketches that are or are not fully defined. Let me get rid of one of these dimensions, and I'll exit the sketch. Notice here in the Feature Manager tree, there is a minus sign in front of the listing of the sketch. This is the indicator that the sketch is underdefined. If I right-click and edit the sketch to put in the missing dimension, when I exit, you can see that the minus sign is gone. Once a sketch is fully defined, there is a way to cause it to become overdefined. This usually happens when you add too many dimensions. For instance, if I edit this sketch once again and add another dimension, Solidworks will tell me right away that there's a problem. It tells me that the sketch is overdefined, and it gives me two options. I can either make this a driven dimension, or I can leave it as a driving dimension. First, I'll choose to make this a driven dimension. Notice that the dimension appears in a gray color. This differentiates it from driving dimensions like these. A driven dimension is just there as a reference to the geometry. It doesn't control the geometry. With a driving dimension, on the other hand, if I double-click it, its value can be changed and the geometry will update. For recap, driven dimensions don't control the geometry. Driving dimensions do control the geometry. If I double-click a driven dimension, Solidworks will tell me that it cannot be changed. So what is the purpose of driven dimensions? They can actually be very useful. For instance, I can put a dimension here to measure the diagonal distance of this rectangle. That way, when I make changes to the width or height, I can see the diagonal distance right away. So that's what you get when you decide to go with driven dimensions. Let's take a look at driving dimensions. These dimensions leave you with a conflict, and lots of yellow. Yellow geometry in Solidworks is not a good thing. The reason for the yellow is that there are two dimensions here, each trying to control the same thing. Also, notice that the Sketch Expert Property Manager appeared, because I have the Always Open This dialog when sketch error occurs enabled. For now, I'll uncheck it and exit the Sketch Expert, since I'll be going over it later. In order to get rid of the problem, you can simply delete one of the over-defining dimensions, and the yellow goes away. Solidworks also has a useful tool for solving these types of errors, called the Sketch Expert. It's useful for larger, more complex sketches, where you aren't sure which dimension or relation to delete. Again, I'll add the same dimension I just deleted and leave it driving to create a conflict. To activate the Sketch Expert, I'll click on the overdefined message in the status bar. Now, in the Property Manager, I have two options for repairing the sketch. The first option is Diagnose. When I press it, Solidworks examines the sketch and automatically finds solutions to create a valid sketch. In the results box, I can scroll through the different solutions. Notice in the graphics area that a slash mark shows which dimension or relation will be deleted. And the last box in the Property Manager lists what will be deleted as well. When I find a solution I am happy with, I can click Accept, and the changes are made. I'll hold off on pressing Accept so I can show you the other method Sketch Expert uses: manual repair. When I select it, conflicting dimensions and relations are listed in the Property Manager. You can go through this list and delete any dimensions or relations that you wish until the sketch is no longer overdefined. In this example, I'll select one of the duplicate dimensions and press Delete. Immediately, the Property Manager displays a message that the sketch can now find a valid solution, so I'll press OK. Depending on the geometry in your sketch, you might also end up with entities highlighted in red that can't be solved. I'll press Ctrl-Tab to switch to another sketch. In this example, you can see a simple sketch with some dimensions already added. Notice that this height is already set to 3 inches. If I put a dimension on this edge and also make it 3 inches, I'm going to have a problem. Solidworks is telling me that by putting in this dimension, I'm causing invalid geometry. If you look at this red line here, you can see that if this edge were allowed to become 3 inches, this line would have to shrink down to nothing. Whenever you run across yellow sketches, or red ones, or any other sketch errors for that matter, always remember that it was probably the very last thing you did that caused the problem. So the easiest way to get out of trouble is to use Undo. Using shaded sketch contours lets you view closed sketch contours as shaded entities. This setting makes it easy to identify closed contours, move closed contours in a single step, quickly apply sketch relations or mirror the sketch entities, and quickly extrude closed contours. However, if you don't want to work with shaded sketch contours, you can easily turn it off by going to the Tools menu, and under Sketch Settings, click Shaded Sketch Contours. When I do, you can see the rectangle is no longer shaded, and if I click and drag it from the center, you can see I can't move it. I can only box select the different entities. With this setting turned off, I'll sketch a circle. And as you can see, Solidworks creates the circle as it normally would. But when I activate the Shaded Sketch Contours setting and sketch a new circle, Solidworks automatically shades it in. Depending on your needs, it will sometimes be beneficial to have shaded sketch contours on or off. If you find yourself often toggling the setting on or off, I recommend adding it to the Command Manager. All you have to do is search for the setting. I'll type Shaded. And once you locate it, click and drag it onto the Command Manager. Now you can easily toggle the option on or off.